Have you ever wondered what the universe looked like when it was just a baby? Well, look no further than the cosmic microwave background, the oldest light in the universe. This incredible phenomenon has allowed us to peer back in time to just 380,000 years after the Big Bang, providing us with invaluable insights into the early universe. So get ready to embark on a journey through time and space as we explore the secrets of the universe's infancy. What is the cosmic microwave background? The cosmic microwave background can help scientists piece together the history of the universe. The cosmic microwave background, CMB, is leftover radiation from the Big Bang, or the time when the universe began. As the theory goes, when the universe was born, it underwent rapid inflation, expansion, and cooling. The universe is still expanding today, and the expansion rate appears different depending on where you look. The CMB represents the heat left over from the Big Bang. You can't see the CMB with your naked eye, but it is everywhere in the universe. It is invisible to humans because it is so cold, just 2.725 degrees above absolute zero, minus 459.67 degrees Fahrenheit, or 273.15 degrees Celsius. This means its radiation is most visible in the microwave part of the electromagnetic spectrum. According to NASA, CMB fills the universe, and in the days before cable TV, every household with television could see the afterglow of the Big Bang opens a new tab. By turning the television to an in-between channel, you could see the CMB as a static signal on the screen. How did the cosmic microwave background form? The universe began 13.8 billion years ago, and the CMB dates back to about 400,000 years after the Big Bang. That's because in the early stages of the universe, when it was just 100 millionth the size it is today, its temperature was extreme. 273 million degrees above absolute zero opens a new tab, according to NASA. Any atoms present at that time were quickly broken apart into small particles, protons, and electrons. The radiation from the CMB and photons, particles representing a quantum of light or other radiation, was scattered off the electrons. Thus, photons wandered through the early universe, just as optical light wanders through a dense fog, NASA wrote. About 380,000 years after the Big Bang, the universe was cool enough that hydrogen could form. Because the CMB photons are barely affected by hitting hydrogen, the photons travel in straight lines. Cosmologists refer to a surface of last scattering, when the CMB photons last hit matter. After that, the universe was too big. So when we map the CMB, we are looking back in time to 380,000 years after the Big Bang, just after the universe was opaque to radiation. What is the cosmic microwave background? Tell us. The CMB is useful to scientists because it helps us learn how the early universe was formed. It is at a uniform temperature with only small fluctuations visible with precise telescopes. By studying these fluctuations, cosmologists can learn about the origin of galaxies and large-scale structures of galaxies, and they can measure the basic parameters of the Big Bang theory, NASA wrote. While portions of the CMB were mapped in the ensuing decades after its discovery, the first space-based full sky map came from NASA's Cosmic Background Explorer, COB mission, which launched in 1989 and ceased science operations in 1993. This baby picture of the universe, as NASA calls it, confirmed Big Bang theory predictions and also showed hints of cosmic structure that were not seen before. In 2006, the Nobel Prize in Physics was awarded to COB scientists John Mather at the NASA Goddard Space Flight Center and George Smoot at the University of California, Berkeley. A more detailed map came in 2003 courtesy of the Wilkinson Microwave Anisotropy Probe, WMAP, which launched in June 2001 and stopped collecting science data in 2010. The first picture pegged the universe's age at 13.7 billion years, a measurement since refined to 13.8 billion years, and also revealed a surprise. The oldest stars started shining about 200 million years after the Big Bang, far earlier than predicted. This light, known as the cosmic microwave background, CMB, marks a time 380,000 years after the universe's birth, when protons and electrons joined to form the first atoms. If scientists can estimate how far light from the CMB traveled to reach Earth, they can calculate the universe's age. Scientists measure the angle in the sky between two distant objects, with Earth and the two objects forming a cosmic triangle. If scientists also know the physical separation between those objects, they can use high school geometry to estimate the distance of the objects from Earth. CMB showed dark matter. Scientists have used the oldest light in the universe to capture an unprecedented glimpse of the distribution of dark matter, an unexplained substance that accounts for most mass in the cosmos around galaxies. Whereas previous observations have mapped out galactic dark matter patterns as far as 10 billion years ago, the new results push that frontier way back to 12 billion years ago. The achievement reveals potential challenges to the standard model of cosmology, a well-corroborated framework that explains much of the strange phenomena that have been observed in space. Relationship to the Big Bang. The CMB is central to the Big Bang theory and modern cosmological models, such as the lambda CDM model. As the theory goes, when the universe was born 13.8 billion years ago, all matter was condensed onto a single point of infinite density and extreme heat. Due to the extreme heat and density of matter, the state of the universe was highly unstable. Suddenly, this point began expanding, and the universe as we know it began. At this time, space was filled with a uniform glow of white-hot plasma particles, which consisted of protons, neutrons, electrons, and photons, light. Between 380,000 and 150 million years after the Big Bang, the photons were constantly interacting with free electrons and could not travel long distances. Hence why this epoch is colloquially referred to as the Dark Ages. In conclusion, the cosmic microwave background is an incredibly powerful tool for understanding the origins and evolution of our universe. By studying this oldest light in the universe, we gain valuable insights into the early universe and the processes that have shaped it into what we see today. The latest advancements in observational techniques and theoretical models have allowed us to make great strides in understanding this ancient light, but there is still so much more to learn. Don't forget to subscribe to our channel, or you will miss our interesting videos.